So here's where we are. Taping, Tony, taping this. So here's what. If you get in your head a little bit, math is a little weird, right?
Yeah.
But we've been doing it for so long that it doesn't seem weird anymore. Like, the fact of the matter is, if someone said, like, subtraction, that's a weird word, right? Like, it doesn't mean anything, but we've been doing it for so long, it's like, oh, it's minusing, right? So if I say 16 minus 7 equals 9, could you rewrite that as an add problem? You guys would have no problem doing that, and you guys realize that these two guys are related to each other. One has the 16 in the problem, and one has the 16 as the answer. And that wouldn't make anything weird for you. At the end, I'll need you to pick up the trash off the floor. Okay, so here's what I need you to realize. So we're watching me real quick. Hey, Gavin, I'm taping, so every time I have to stop, it's awkward for anyone listening. So if I have to stop again, I'm going to ask you to leave so I can keep taping. Is that all right?
Yeah.
Thank you so much. So here's what I want you to realize. If I am taking 5 times 4 equals 20, and I say rewrite it as a division problem, there's actually a bunch of ways you could do it. You could go 20 divided by 4 equals 5. You could do 20 over 4 equals 5. And you could even do that box thing. Remember, the 20 goes inside, the 4 goes on the outside, the 5 goes up here. And none of that is weird to you. None of that is weird to you. You're like, yeah, if you undo multiply, you get divide. And if you undo divide, you get multiply. None of that is weird to you. You guys walk right through this. We're going to learn a new way to do math. And what I want you to realize, because I've had kids over years of doing this, they'll be like, but what is a logarithm? And what we're doing is we are doing the opposite of finding the power of something. So I'm going to walk you through that. So here's what I want you to start with. You don't have to write this, you're just watching. If we have 5 to the second, that is an exponent problem. I am saying 5 to the second, 5 times 5 gives you 25. And most of us don't even do it, like we just do it in our head. 5 seconds, that's 25, right? What you guys don't realize is if I put it like this, and I say to you, what exponent will give me 25, you are actually undoing this problem, and you didn't know it, but the name for that is called taking the log. The action of undoing an exponent is taking the log, and you just didn't know that. And you're thinking, so why is this a thing? So we did this problem 2 days ago. We said 3 to the what would give me 9. 3 to the what power gives us 9? 2, right? 3 to the second. What about 3 to the what would give me 27? 3 to the 3. And you guys are super good at it. Let me tell you where we're heading now in this class. We are heading to this problem right here. 3 to the what gives us 19. And that's a problem, because we don't know what 3 to what will give me 19. And I'm going to show you what it actually is. It actually is 2.68. It's somewhere between 2 and 3, and it's 2.68. And the way I know that is because I used my calculator this morning, and I used a little button called LOG, right? That's where we're heading. We're actually going to be, this is a problem off your test that will look like this. Let me change that. 3 to the 2x minus 5 equals 8.7. That is literally a problem off of your test. That's where we're heading. But we need more tools, right? And we need to know how to use those damn buttons on our calculator, because none of us want to do that in our head. So today, I'm giving you the very basics. We are learning how to take an exponent problem and rewrite it as a log problem. So it's weird, but it's easy if you like kind of just let your mind feel like, oh, I'm just moving stuff around. Are you ready? So turn your papers over. Let's learn about our new friend, Mr. Log. And I am giving, you got it?
Yeah, I gave you the.
I got it, okay. So here we go. The first thing I want you to write down is two things. A logarithm is another way of writing exponents, and I want you to write this, where the exponent is the answer. Here's what I mean by that. Don't write this next thing down. 5 times 4 equals 20. I can rewrite that with the 4 being the answer. I can say 20 divided by 5 equals 4. That way the 4 is the answer. Sometimes he's in the middle of the problem, and sometimes I can write it so he's the answer. That's what we're doing today, is we're going to be taking problems where the exponent is way up high, and we don't like that, and we're going to rewrite it in a new way. So here's how it goes. It's kind of weird, and you're going to write this down. So we're going to say this. I'm going to give you an exponent that you're used to. 5 to the second equals 25. That is not weird for you. You guys totally get that. 5 to the second is 25. But what if I want a way to write this guy where the 2 is the answer? Because some of our problems will need to know the exponent. So here's what we do. Now the first thing I got to tell you is logs are disappointing. You know, multiply has that cool symbol, and divide has a bunch of cool symbols. It's got this, and it's got this, and square root has that cool symbols. Lots of cool symbols. It turns out that logs were made up about 400 years ago, which in math terms is not that long ago, when the printing press came out. So they could have come up with a really cool symbol, like, oh, I don't know, a curlicue. Or they could have come up with like a squiggly line to mean log. They didn't. This is the symbol for logs. It's super, super disappointing. That's it. That's all they do, right?
Or they confuse it.
They don't do anything. So when you see that little word there, and here's why, because they were doing the printing press, and they could write it out. So is it disappointing to me? Yes. So what we're going to do is we're going to take this guy, and we're going to rewrite these pieces. We're going to rewrite this guy. He needs to be somewhere new. This guy needs to be somewhere new. And this guy needs to be somewhere new. We're going to use 5 squared and 25. And here's how we do it. We say the log of the base. The base in this case is 5. That's our base number. And you know where he goes? In the basement. I put him down low. The base goes in the basement. Now the whole point of this is to make the exponent the answer. So he's going to go over there. And I got to put that stupid 25 somewhere. He's actually called the argument. And he's going to go in this space right here. He's going to go in this space right here. So let me tell you what this actually means. What this actually means is this. If I was doing a log problem, I would say log of base 5 of 25. And what I'm saying to myself is this. 5 to the what would give me 25? 5 to the second. The answer is the exponent. Does that make sense? So when we're doing logs, what we're trying to find out is, if this is my base, and this is what I wanted to turn into, what exponent would I use? That's what we're doing. Yes?
So, like this question will be right out, like log 5, 25, and it would be like equal blank, and then
Yes.
we'll have to figure out.
Yes,
Okay.
yes, and we'll start doing trickier ones. So here's what I want you also to write out. I'm going to show this to you in another way right now that doesn't have numbers in it. So I want you to write this out. If my base is my right there, and x is my exponent, and a is my answer, right? I got an exponent, I got a base, I got an exponent, I got an answer. If I want to rewrite it using logs, I say log. The b goes where? Down. It goes in the basement. It goes in the basement. the exponent is my answer, and that a, I just got to put them right there. So what I'm asking you would be b to the what power would turn into a, right? That's what a log is. It's instead of me giving you the exponent, you've got to figure the exponent out, right? Okay, so here we go. We're going to try some. You guys, I messed this up. I want you to jump down to the next set of problems. Every year I tell myself, don't forget to fix this. What we're going to do, oh no, was that right? No, we're going to start, yeah, we're going to start here. We're going to start here. So here's what I want to start with. Everyone see this on your notes? Let's start here. We're going to take this guy and rewrite him as a log. You ready? So here we go. Let's do this first one together. We're going to write the word log. Where does that 8 go? In the bottom. I put the 64 next, and the exponent is always the answer. Yeah? So can you do me a favor? Can you do the next 3 problems on your thing? We're just practicing writing these out. But it's one of those things that it's weird, like what the holy hell are we doing? And then we're going to use this technique, and it's going to make our math super easy. But if you don't understand the basics, no lie, about 20% of you are going to come to me right before the test and be like, I don't really get how to do logs. And my answer will be, sad face, because it'll be too late. So check yours off mine. How did you do? Did you get log 7 of 1 equals 0? Yeah? Does that look right for you? Did you get log 749 equals 2? Oh, sorry. I'll let you do the last one. The key to remember is the exponent is the answer. That's where kids mess up. The base and the basement, everyone gets. But you gotta remember the exponent is the answer. I knew that. I was testing you. Woo. There he is. Sorry, kids at home. So take a look at this last one. Log 169. It can be a crazy number of 13 equals 1/2. You know what that means? That means if I square root 169, I get 13. So now let's pop back to the other ones. Can you go the other way? Can you write a log as an exponent? And once you get the hang of it, they're so easy. Just remember, my base comes from the basement, my exponent is the answer, and I get 27. These are all real, so they should work. I'm going to walk around and make sure everyone's okay on these ones. Thank you for doing this. I totally appreciate it. You guys got it. And if you're thinking, is this as easy as it is today? It is. It's just learning a new way to write it, right? But it's weird. I'm going to show you a problem in a little bit, and you can take it home and say to your parents, if you can do this, I'll give you $20, and if you can't, and I can, you give me $20, and you all get $20. Because it's scary. How about this? Did you get something that looks like this? Did you get 14 squared 196? It is, but it's weird. It's weird. It's new. 81 to the 1/2 equals 9, and 12 to the 12 equals 1. No, that's wrong. 12 to the 1 equals 12. Ooh, almost messed that one up. Okay, so you're thinking, Ms. T, those are really easy, and it's critical that you get that. But let's now use it. Let's use it, okay? So here we go. There are 2 ways to do these problems. Some of you are going to be able to actually do the log in your head because you didn't realize that you've been doing logs this whole time. What this problem is saying is this. It is saying 4 to what power will give me 16? 4 to the what power gives me 16? 4 to the second power. So in other words, x is 2. Now if you're thinking, Miss T, I don't always see that, you can rewrite it as 4 to the what gives me 16. And for a lot of kids, that's an easier way to do it if you can see it, right? So let's try this one. What it's saying is 3 to the what power is 27. If you can do that in your head, you don't have to rewrite it because you can do the log. 3 to the something gives me 27. Oh, that would be 3, right? 3 to the third. Now, here's what's interesting. I can put that x anywhere I want. This guy is saying 7 to the second gives me x. What is 7 to the second? 49. It's 49. X is 49. I can even put the x down here, and it's super easy. It's saying x to the what? To the second gives me 25. Well, you know how to do that. It's 5. But look how crazy that looks. That looks like it's a hard, like if I showed you this an hour ago and I said solve that, you'd be like, that's gypsy magic, can't do it. Right? There's no way. I can't do it. But you can. You totally can. Okay. Last ones, best ones. Some of them I do have to rewrite because they are tricky. So Lucas, you might want to watch these ones because these ones are a little weird. Here you go. These are the ones you want to show your parents and challenge them because they'll be like, that's impressive.
What is
right?
that?
So here's what we're going to do. Let's rewrite this problem into exponential form. It will make it so easy. You're going to be like, what? That's so easy. 3 to the 1 equals x minus 5. 3 equals x minus 5. X equals 8. Try the last one on your own. Rewrite it as an exponential, and all of a sudden, it's super easy. Because really what you're saying is 6 to the second power equals 2x minus 4. They're super easy. We're just rewriting it. Six to the 2. I'm not just setting it up. I'm just setting it up. What's on it? $36 equals 2x minus 4. 40 equals 2x. X equals 20. There you go. So goodbye, my friends at home. Just to me.